So you have these three things, and it's simpler to look at. And again, this is my interpretation of this issue. But as I look at what it was that I'm seeing here, it didn't fit in any of these. Now, remember, all life is supposed to fit in these three categories. And in one of the three categories, it's not allowed to cross over from one to another. So, what I'm seeing didn't fit any of them. And then if you actually look at what is happening, they're crossing the lines between them. They're crossing the lines in terms of their characteristics and structures and life cycles. And this makes no sense at all from a conventional standpoint. It makes no sense. Because what I was seeing, and am seeing, is I'm seeing something that has some very strong bacterial-like qualities. And now I have to qualify, as I qualify a lot, I suppose, but I have to qualify the use of bacteria as bacterial-like. And I've always qualified it, but even more so now, and that's to emphasize the point, that these structures that I'm seeing, and the structure that I'm talking about, they're occurring within the filaments that most of us have heard about or are familiar. Most of us think of the Morgellons condition as being represented basically by a filament. My work has been to sort of dig into that interior of that filament to find out what's happening inside. And indeed, there's a whole lot happening inside. And the filament, to me, I regard as simply the carrier of what's going on, simply a transport or housing vehicle, and not at all the real essence and substance of this condition. So I'm seeing a bacterial-like structure, two of them actually, and they have some similarities to bacteria, and particularly an organism called chlamydia pneumonia. There's, bacteria don't live inside of a cell very often. And this particular structure we're talking about lives inside the cell. And there is a class of conventional bacteria called chlamydia that actually do live inside the cell. They can be found within red blood cells, totally separate from this work. And what happens is they feed off the energy of that cell. They don't have a complete metabolism by themselves. It's not whole. And so they feed off of the energy basically inherent within that cell. So they're interior. And if you have something interior to a cell, it's much, much harder for the immune system to be able to detect its existence and or do anything to eradicate it. So this is one bacterial type. But then you have these problems that these particular structures that are being looked at have the ability to withstand extremely hostile conditions. Hostile conditions in terms of heat, and hostile conditions in terms of heat and cold, I guess I would say, and hostile conditions in terms of chemistry. We sterilize things frequently by boiling water, and this is one way. We boil water and it sterilizes most things. Well, some of that work early in the year, in fact, some work I never even reported on, was some work where I had boiled a sample. It was an air filter sample. And let's just say that the boiling had no effect upon it. It did not stop the process of what it was that I was looking at. That was very early in the game. So it was apparent to me early that, this thing was very hardy, to say the very least. But over time, it's beyond being hardy. It just plain doesn't die under conventional conditions that you would think would kill bacteria, this type of thing. And the other chemistry that I got involved with was strong bases or alkali solutions, are basically lye. And learning that even when this structure and organism was put into a lye solution, again, that didn't actually kill it. It may have put it into a dormant state, but it didn't kill it. So this is, and again, this is something that was accepted. It was accepted without comment or scrutiny. But over time, and particularly that particular day when I wrote this paper, or had the idea to write this paper, That makes no sense. There's nothing. You can't find a bacteria that can hold up to that type of adversity. It just doesn't exist. There's no bacteria that holds up to that type of thing. That is why they created that new domain, because it was so unusual. That Archaea domain, the work that's going on with beginning to look for life on other planets, well, that's what they're looking for. That's the first thing they expect to find is Archaea, because they can exist in essentially conditions that are completely inhospitable to us. And so the last one is the one that really crosses and separates all boundaries. And as usual, I'm not making it on my time schedule, am I? That's pretty common for me. But nevertheless, it's all part of the same basis that we need to build if you have an interest. But the third one is this, what I would call erythrocytic form. An erythrocyte is a red blood cell. The introduction of that work, revealing the existence of red blood cells within unusual sampling, not expected, namely air sampling and water sampling, that was a pretty hot topic, still is, I suppose, in its own way, but that was a pretty hot topic when it came out because it had no basis or connection with anything that we knew of. It made no sense to any of us. How could you possibly have a red blood cell structure existing within air samples on a repeated basis? I remember I actually like to be familiar with all of the counter-arguments as many as I can, because that's helpful to us, because if something is wrong, well, we want to know that as soon as we can. But a lot of times the counter-arguments may not make sense, but they need to be taken seriously, at least to put them into perspective, I would say. And, I remember the claim that came out when I first reported on the blood cells, and I was being told that there must be, that's the kind of phrase I would use, there must be fish fertilizer plants in my area. And, at that time, well, we're still out of town, but I lived quite a bit out of town. There's no industry whatsoever. Santa Fe, go outside of Santa Fe 10 miles and you're in a pretty desert, rural-like environment. So, when a question's raised, I say, all right, I wonder if there's a fish factory around, a fish fertilizer factory. And I'm sorry, there's no fish fertilizer factory running around explaining the problem. And then the extent of the problem, meaning the range of the problem, goes way beyond any fish factory. So certain ideas, although they're proposed, they have to be examined and eliminated, and that was eliminated fairly easily. But it was a difficult subject for many of us to confront. It certainly is disturbing. There's no question about that. But it happened over and over and over. When I do my work, it's very rare that I would do things at one time. I'll usually do them several times before I'll even report on them. And this blood thing would not go away. And if you actually go back, if you want to be curious and you get into the history, go back to the very first paper. Oh man, I forget what that's called, but it has a structure sort of like a grape cluster on it. That was the first time. That was right after the issue started that you had a medical person. It wasn't me. You had a medical person invite me down to look under the microscope at something he was seeing. And he wanted to show me that he was seeing things that I could not see with my microscope. And if you look at his identification right at the beginning, it was basically an erythrocyte, clearly stated. It's had nothing to do with me. It's probably a couple years later before I start finding that on my own with my microscope work, because the microscope work improved over the years. But it came up, and it came up over and over and over, and I continued to try to improve my techniques of imagery so that we could get a good picture of what was going on, good measurements and this type of thing. Suffice it to say, at this point, I think the evidence is fairly well established that there is the structure that matches in all ways. You can go across the board. Eventually, it involves some forensic tests. You'll find a paper I did on forensic tests for the existence of hemoglobin. It took me 2 to 3 months at least to get through that work. But I truly wanted to know, did this match an erythrocyte? Because it certainly matches, down to the submicron as well as structure. Well, it has. All the evidence is consistent. So, any of us try to put these 3 things together